Hello, Tom from Every Step Calculus, EveryStepPhysics.com. A problem in calculus regarding line integrals, one of the most pathetic sections of calculus, completely worthless, just really puzzles. So all calculus is puzzles, like Sudoku puzzles. And then some professor will say that it's important for something else, and I've never found that after 25 years. So anyways, let's do this so you can pass your test here. Here's a question that some kid put in, and I'm going to show you how that works in my programs. Index 8 to get to my menu. I'm going to scroll down here to line integrals. That's the subject matter. There's line integrals here, and we're going to go number 6 here, dx dy, because that's what they're asking here, dx and dy. Okay, so then we're going to choose that in the menu number 6. I press the number or scroll to it. I've already entered the functions in here to save time with the simulator here. So here's what the function is, the integral, dx dy. You'd put that in yourself, pressing alpha first, and then you have a choice of saying it's okay, or you can change it in case you made a mistake, but you're going to enter that yourself by pressing alpha first. Remember that. And there's line segments given. Yes, they are, and they're xy and x2 y2, because they give you x and y, and then x2 y2. Say OK, and I've put these in already. 2, 1, and minus 1, 0. Looks pretty good, so that we're going to say OK to that. And we're going to parameterize it, change it with t values, and here's the formula trick for that. Remember this is the big trick. Took me quite a while to figure this out from the way professors teach things, and they skip the easy stuff, which is tough for maybe you or me, and we do the y value. That's what it is. And anytime you're parameterizing a function, the range becomes 0 to 1. Okay, remember that. So now we have the x, and now we're going to do the derivative of that, which is minus 3. Here's the y value that we got, and we're going to do the derivative of that, which is minus 1. The original integral is this. Okay, now we're going to substitute all this in here. Putting the 1 in, just like it says, I have quotation marks here, which this simulator does, but you're going to put parentheses around this on your paper, okay? Because remember, they want to explain each step, etc., and you get points for each step you do. And so you're going to add all these. Anytime you see quotation marks, you're going to put a left or right parentheses, okay, to clean it up. And then we do the actual math of that, which is this, okay? We're going to integrate it. Of course, you could do that without this help, right? No problem. Just anybody can do integrals really easy. I don't think so. And we're going to, at t equals 1, which is the upper limit, we're going to enter the 1 for all the x's, etc. We're going to enter the 0 at t equals 0. We're going to enter the 0 for all the x's, okay? And that equals 0. And the other one was 5, so take the upper limit minus the lower limit, 5 minus 0, and here's the answer, 5 units, okay? Now we don't even know what units are. I mean, what are we doing with line integrals? Let's see, we're finding the distance or something around this thing. This is all Pythagorean theorem anyways, so. But what do we care? We just need to pass the test. So go to my site, buy my program. They're only $40. You get over 370 programs in your calculator to answer most of test problems in calculus, and you're going to get 6 or 7 or 8 right versus the person sitting next to you, and that's all you need because of the class curve to pass that class or maybe get even an A. So think about that, okay? The price is pretty cheap compared to what you're paying for college nowadays. So think about that. Go to my site, buy my programs, and pass calculus. Hey, have a good one.